Hello, welcome back to this class on sequential logic circuits. So in last class, we discussed about this SR-Latch and we come to know about the functional table of SR-Latch with NAND-Gate. So let us just revise it. So this is the input and this is the output. S and R, these are the input. Q and Q bar, these are the two outputs. So here these are the outputs and these are the inputs. So as we have seen previously, if I write here S is equal to 1 and R is equal to 0, so as far as as soon as 0 is available at the input of NAND gate, you will get the output 1. And this 1 is coming here, the 1 will be 0. So you see Q is equal to 0, Q bar is equal to 1, and S in the case of S is equal to 1 and R is equal to 0. So this is how we verify this functional table of SR-Latch with the, which is made of NAND gate. Now after that, if 1 is there, so this is 1 and this is 1. So as I told you before that we have to see now what is the condition of other input of this NAND gate number 1 and number 2. So we see there the output of Q bar is equal to 1. So 1 will be again 0. This 0 will come here and from 1 to 1. Any 0 makes output 1. So you see same condition 1 1. So Q is 0 and Q bar is 1. So it means after S is equal to 1 and R is equal to 0, there is no change in the output. It retains the previous value. Now take the another case when S is equal to 0. So let me erase so that you should not confuse. This one. Okay, take these values. So I am taking now S is equal to 0 and R is equal to 1. This is another case. So what is going on here? Any 0 makes output 1, Q will be 1. And this 1 is coming here, 1 will make output 0. So you see here, Q is equal to 1, Q bar is equal to 0. Now after this, if 1 is available, 1 and 1. As you know, if the input of NAND gate is 1, we cannot take decision what shall be the output. We have to look what is the status of another input also. So in that case, we see Q is equal to 1 and R is equal to already 1. So 1 will be 0. And the 0 is coming here. 0 and 1 will make output 1. This any 0 makes output 1. So now this is changed from 1 to 1 means there is no change as such. And this 0 to 0 means there is no change. So output is Q is equal to 1. Here it is written. And Q bar is equal to 0. Here it is written. It means when S is equal to 0 and R is equal to 1, the output will be this. And now the last case. You see last case. Let me erase it. Although it is a kind of revision, we have already done it. But from the book, I wish to tell you so that there should be some continuity or you should build some confidence. Now, last case is 0 0. So as I told you before, 0 0, any 0 makes output 1. So both Q and Q bar wants to make 1. This is not possible. That is why forbidden state. If Q is equal to 1, how can be Q bar is equal to 1? It has to be 0. because both are complementary. If it is 1, this will be 0 or vice versa. So this was all about this SR-Latch with the help of NAND-Gate. Same goes with the NOR gate also, same structure, NOR gate 1, NOR gate 2. And here situation will be what 1. Okay. So suppose this is 1 and this is 0. We have to understand about this NOR gate. In which condition NOR gate gives the output 1 or what. So you can write here NOR gate output. Suppose A and B, 2 input, and Y is the output of a NOR gate. NOR gate is nothing but OR gate and NOT gate. This is OR gate and one NOT gate. This is Y. So this is Y prime, suppose is at the output. So take the all possible combinations. So 0, 0, 0, 1, 1, 0, 1, 1. So for 0, 0, put here 0, 0. So 0 plus, basically this logical expression is like this, A plus B whole bar, right? But up to here it is A plus B, and this is not gate, so whole bar, okay? So 0 plus 0 will be 0, and complement of 0 will be 1. 0 plus 1 will be 1, and complement of 1 will be 0. 1 plus 0 will be 1, and complement of 1 will be 0. Here 1 plus 1 will be 1. This is not algebraic, this is logical. So like 2, this is 2, this is 2. So 1 plus 1 will be 1, and complement of 1 will be 0. So here you can see any 1 in the input makes output 0. So this is the truth table of NOR gate. So any 1 in the input makes output 1. So that is the step 1. However, in order to have logic 1, it has to be both logic 0. So let us see here what is going on. S is equal to 1 and R is equal to 0. This is the case. So any 1 input output becomes 0. That immediately we can see from here. Any 1. One of the input is logic 1. So output will be 0. And this 0, 0 will output make 1. So you can see here S is equal to 1, R is equal to 0, Q is equal to 1, Q bar is equal to 0. So this is verified. Now take another situation. After that, if we give 0, 0, so here this is 0, this is 0. So you see, we have to we can take decision if any one is any one of the input of NOR gate is equal to 1, then only output will be 0. But here both inputs are for both NOR gate, input 0 is available. So we cannot take decision. We have to look the other input. So what is the other input? So from here we can see this is logic 1. Logic 1 is coming here. This is 0. So 0 and 1, 0, 1 will make output 0. And this 0 will go here. 0, 0 will make output 1. So what we are observing that Q is 1, Q bar is 0, and case is 0, 0. So please mind it. Earlier, in case of NAND-Gate, this 0, 0 was the forbidden state. Now here it is 1, 0. 1, 0 means here we compare to, this is what it is written here. After S is equal to 1, R is equal to 0, you will get this output. Set. Okay, and reset. So it means this is no change condition in the output when 0, 0 is available. It will give the previous output. Now take the other case. If S is equal to 0 or S is equal to 0, R is equal to 1. So in that case, you will find here any 1 of the input if logic 1, then output will be 1. That is why it is called Q bar is equal to 1. And this 0 will make 0 will make output 0. So that is why it is 0. And after that, if you give 0, 0, so there will be no change. However, for 1, 1, if it is a here 1, let me use other things. So if both are 1, 1, so we are looking that any one of the input if logic 1, so it will give to logic 0. But if it is logic 0, if Q is the logic 0, Q bar has to be logic 1. But as per truth table, any one makes output 0. So here it wants to be 0, here also it wants to be 0, the way it is there, which is not a permissible state. That is like forbidden. So this is the difference, basic difference between latch made by NOR gate and latch made by NAND gate. So here 0, 0 state is forbidden, and here 1, 1 state is the forbidden. So I hope you could understand, and this is the clock pulse. So based on this positive one, and here NAND gate is this one. So this is logic 1 and this is logic 0. So okay, so this is the truth table. Now we will move to the flip-flop. Here you can see some clock pulse is given, written as enable. Okay, EN stand for enable, is high active enable. So for simplicity, you can say this is the what is called a clock pulse. Okay, if clock pulse is 0, so the entire circuit will be no change. Okay, so suppose this is 0, so as you told 0, 0, both will be 1, 1. Okay, so for that case, if both are 1, 1, we have to look what is the another state, and in this way there will be no change in the output, because this whatever output will be was available earlier, the same output will be here also. Now let us try to understand. Actually, for this case, let me use this what is called Jamboard to make you understand. Let me show whether you are able to see or not. Yeah, this is Jamboard. And yeah, so for second, I will draw this SR flip-flop SR flip-flop. SR flip-flop. So SR, the diagram of SR flip-flop looks like this. This is one NAND gate. This is another NAND gate. And it is connected in cross-coupled manner. This is here. So this is a kind of SR-Latch which we have seen earlier. This is Q, this is Q bar. But only difference is that from SR-Latch to SR flip-flop, there is one more NAND gate where we will give here S, this will be here R, and the common enable circuit. Here to written enable, or we can write clock also. Okay. So first thing is clock is going on here, and this is the output. So let us try to understand this truth table or functional table, more specifically functional table. Functional table. So this side we will write input, and what are those input? So what I will try to write in another way, it's like that. Since this is flip-flop, so let us see, this is the QT, and this is S, and this is R. These are the three input, and we are interested in what is the next output, QT plus 1. This is QT means past output, or say present output, and QT plus 1 is the next output. So we are concerned about that. Now it becomes your 3-bit input. This is the output. Okay. I'm not writing that q bar t plus 1. That is understood. We can just write the complement of q bar t plus 1. Okay. So now this is 3-bit input. We just simply write 3-bit all combination 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1. So these are the inputs. So now let us try to find out what is the value at the output for each combination. So Qt is here. We can write this way. Okay. And Qt plus 1 will be here only, but after propagating the inputs through the circuit. So let us assume one by one case. So presently Qt is 0. So let us write here 0. S is equal to 0. Let us write here S is equal to 0. R is equal to 0. And a clock pulse, positive clock pulse has come. This is what? Logic 1. So as I told you before that any input 1 in the, sorry, any input 0 in the NAND gate makes output 1. So here we will get logic 1. Similarly here, because logic 0 is here, add that it will give 1. Now for this NAND gate, let me write the number 1, 2, 3, 4. So one of the input of NAND gate number 3 is 1. Similarly, one of the input of NAND gate number 4 is 1. So what will be the output we do not know, or we cannot determine unless we know the status of other input here. So we see here Qt is equal to 0. So 0 will be available here. So now the output of NAND gate number 4 you can easily predict. So any 0 makes output 1, and this 1 is coming here. So 1 will be 0. So it will be here only this 0, from 0 to 0. So next state, this was the earlier state. Now Qt plus 1 will be 0. So I will write here 0. Okay. So now take another case. This one, if it is 0, okay. Let me look here so that it should not confuse. Change the color. Let us take it this one. So Qt is 0, is what? And I will remove these things. Oh. Okay, no problem. I will write down it. Okay. So Qt is 0 here. S is equal to 0. R is equal to 1. And this clock pulse has come. So NAND gate number 1 will give output immediately 1, since any 0 gives output 1. However, below both are 1, 1, output will be 0. So here you see NAND gate number 4 has 1 input is equal to 0. So what will happen? It will give immediately logic 1. And this 1 is coming here. 1, 1 will make output 0. So next state, earlier it was 0, now next state will be 0. Okay. So now let us consider third case. It is again a 0. Let me see now. First I will remove all this in this one. So this is the case number 3. This is 0. S is equal to what? R is equal to 0. And this is clock 1. So any 0 makes output 1. And this is 1, 1. Output makes 0. So here NAND gate number 3 will give immediately logic 1 as output, because any 1 is 0. Any one of the input is 0. So now state will be from 0 to 1. Qt plus 1 will be 1. And this one will come here, what will be 0. Okay, the complement of this. Now, next state, let us understand. So I will get this is here. Next state is Qt is equal to 0, S is equal to 1, R is equal to 1. What will be the next state? What word will make output 0? Here, what word will make output 0? So earlier it is here 0, so 0 will be available here. So immediately it will make output what? This one. So from here, so again situation is same. Just you see 0 and 0. So there will be some race between NAND-Gate number 3 and NAND-Gate number 4. This and this. Both wanted to give the logic 1. This one also, this one also. But as we have seen in case of NAND-Latch, when both inputs are 1, this was the forbidden state, or we cannot determine indeterminate state. So that state is cannot be determined. So we write here cross, that is indeterminate state. I can write indeterminate state. So when both S and R are 1, the clock pulse has come, we cannot predict the correct value. It is unpredictable. Anyone can be 1, and if one of the input is 1, so it will, one of the output is 1, then it will compel others to go to 0. But that is not fixed. So now let us move to next state. I hope you could understand, because this 1 state. Now this one Qt is 1, and both are here, S and R are 0, and clock pulse has come. So what will happen? This NAND-Gate number 1 will give output 1, NAND-Gate number 2 also will give output 1. 3 and 4 will look into what is the status of second input. So here this is what? Qt is equal to 1. So this is fixed now. So what will be 0? And this 0 is available here. 0 makes output 1. So it will be logic 1. Okay. Similarly, now go for this. So this is 1. This is logic 1. This will be logic 0. So here AB 0 makes output 1. 1 will be 0. So this 0 will force gate number 3 is equal to 1. Okay. So and other one will make output 0. So here next output is 1. Okay. Now both are 1. This is what that we use previously, so that you should not get confused. So we are considering this state last. So Qt is 1, S is equal to 1, R is equal to 1. Both are 1. So 1 means here 0, 1 means here 0. So now again same situation occurs the way we got S is equal to 1 and R is equal to 1. So there will be race and we cannot determine the output. So we just simply put dot. So this way we are able to write the functional table. So with the help of truth table, we can write the characteristic equation also. Characteristic equation. So let me draw 3 variable T web. So here I will write T bar T, here T, here S by R bar, S by R, SR, SR bar. So let us fill up the values. Input. So 0 here, 0 here, this is 1 here, this is not clear here. This is what here. This what will be here. I think something is missing. Okay. 0, 0, 2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Oh, one case is missing here. That is 5. Not 0, 1. Okay. So 1, 0, 1. Okay, let me write its value. It will be 0 here. Okay, you can cross check, no problem. So we were here 0. This is 1. Then it will be here 0. Then it will be what? And another will be cross. Sorry for this inconvenience. So all possible combinations are here. You can cross check anytime. So all it takes. Now we want to simplify this schema. So we can make easily here quad group of 4 ones by considering this dot here as a 1. And in order to include this, we can make a pair of these corner ones by folding this cut off here. So let us see what will be the expression. Expression of output, that is the Q3 plus 1, will be what? From here we can see it is S simply, and from here we can see R bar Qt. This is the characteristic equation. And this characteristic equation is here. You just see S Qt plus 1 is equal to S. So Qt plus 1, this is Qt plus 1, and this is your S. So S, so for first 3 value, you just see from here to here. You see here, it follows S. Output follows S. 0, 0, 0, 0, 1, 1. This is what is the meaning of here. And since this is not here, we will consider from here. Now next, these cases are R bar. R bar means if it is 0, then it will be 1. Here. If R is equal to 1, Qt plus 1 will be 0. If R is equal to 0, Qt plus 1 will be 1. So this is the meaning of it here. So this is the characteristic equation of SR-Flip-Flop. So let us see what is the this. Let me see. Yeah, you are able to see that one only. So here the same thing, same diagram is here. That SR-Latch with control input, this SR-Flip-Flop basically. So as I told you, Qt plus 1, Qt plus 1 is equal to S plus R bar Qt. This is R bar. So you can see for 0, 0, whatever S is there, so no change. For 0, 0, enable is 1. For this one, S is 0 and R is equal to 1. For this case, Q is equal to 0. Means whatever S is there, same is following here. Whatever S is there, same is following here. And what word is that? Indeterminate state. This is what we have learned earlier also. Okay. So in compressed form it is written, and for all cases En is 1. If En that enable is 0, means circuit is non-functional. There is no change. Whatever output is there, it will be same. Whatever you change. If you take S equal to 0, 0, 0, 1, 1, 0, 1, 1, there will be no change in the output. Okay, whatever output it just take, it will return like that. So I hope you could understand this SR-Flip-Flop. And there is a, okay, this latch. Let me show the graphic symbol for latches. SR, this is S and R, this is Q1, Q bar as an output. And for negative logic, this is the symbol. And this is the D flip-flop. This is the just extension of SR flip-flop. Here you can see this up to here. This is the SR flip-flop. This was the S, this was the R. But in that there was a indeterminate state when S is equal to 1 and R is equal to 1. Both are 1. We cannot determine what shall be the output. Output was Qt plus 1 is equal to dot. So in order to avoid that state, we put here a NAND-Gate. So we use this, we implement this NAND-Gate with the help of NAND-Gate only. So I used to draw like this. Okay, this is also NAND-Gate. Yeah. So D-Latch or D-Flip-Flop is an extension of SR-Flip-Flop. And this is the symbol. Only one input. In SR, we have two inputs. Storage element. So these are the some responses. This positive response to positive level is at this when output, when there is a transition in the clock pulse, but triggering is occurring at this level, at the level, positive level. Then this is called level triggering. If there is a change in the state of flip-flop at rising edge of the pulse, this is the rising edge of the pulse. This is the positive rising edge of the pulse. At that instant, if there is a change in the state of flip-flop, that mechanism is called positive edge triggering or response. If you have designed your circuit to change its state based on falling edge of clock pulse, these are the falling edge or trailing edge, then it is called negative edge response. So these are the different kind of clock. So edge trigger, positive edge, negative edge. Or there, we will not go in that detail, but what I would like to say here, D is there in the SR-Latch, SR-Flip-Flop table. Now, what I was trying to tell Qt plus 1 is explained here. So Qt plus 1, that is the characteristic equation of D flip-flop is given here. Characteristic equation of GK flip-flop is here. Characteristic equation of T flip-flop is here. This is GK, this is D. SR is not given. So SR we can write here. Qt plus 1 is equal to S plus R bar Qt. This was the characteristic equation of SR-Flip-Flop. So with this, thank you so much for attending. We will soon meet in next class. Thank you.